Hello, welcome back. The last couple of lecture, we got to know about LD and LW assembly instruction. Now at this moment, we will practice debugging the LD and LW assembly instruction together using TRACE32 debugging program. So what you are looking at is LD and LW assembly instruction. So let's perform the first assembly instruction. So this window is instruction window with the address. Please take a look at this. Here is another window that is register window. In this window, the value of the set of general purple register can be displayed. And another window we are going to use is the memory window that will be used in this lecture during this debugging practice. So now, before running this assembly instruction, let's analyze syntax of this assembly instruction together. Here is the assembly instruction. As we discussed in the previous lecture, whenever you look at LD assembly instruction, we have to think about this assembly instruction works in two steps. First step is to find out the target address to load, because LD instruction performs load operation from the memory area. And the second step is to get the data from the target, the memory address. The first thing you have to do is to check the value of the S3 register. S3 register in this case can be considered the base register. And then this value, this is the offset. This should be added to the value of S3 register. So this operation can be represent this equation. And please take a look at this. And next thing we have to do is to read the value at this target address. So now let's take a look at the window, register window, to see the value of the S3 register. S3 register has this address. Please take a look at this. Here is the value of the S3 register. So I will copy the value of the S3 register, and this is the address to load the data. And then this is offset that could be added to this address. As a result, we can expect that target address will be this address. This will be the target address. Please take a look at this. So I am making some sort of equation. So this is target address. So in order to check the data at this target address, so we need to look at another window. So in the TRACE32, the program, and it support another command, that is d.v, and this command, it allows the memory view of this target address. I will copy this command to run in this terminal. Please take a look at this. So let me type. So as you can see, that this window contains address and each address, and you are going to see the memory content. the memory content is displayed in the 8-byte format, 8-byte manner. And important thing you got to know is that at this address, and this value can be seen. So now that you got to know about which data are placed in the target address, and next thing you have to do is to run this instruction to see the result of this assembly instruction. So I am going to click the start button. After I click the start button, please pay attention to the value of A5 register, because A5 register is destination register for this instruction. So here you go. So please take a look at this. A5 register is updated to this value. So for better understanding, let's revert this assembly instruction again by using r.undo command. This command is supported in TRACE32. Before running LD instruction, the A5 register hold this value 0x1. So here you go. Let me run again. Please take a look at this. A5 register is updated to have this value. This value comes from this memory target address. Now that we just run the first assembly instruction, that is LD assembly instruction. The next assembly instruction we are going to perform execute is LW assembly instruction rather than LW assembly instruction. As for LD assembly instruction, the data size to load is 8 byte because A5 register has this value. So please pay attention to the value of A5 register. A5 register updated to have this value. But as for this assembly instruction, and we can expect that the size of the data to load could be 4 byte instead of 8 byte because an LW assembly instruction support 4 byte load operation. Now let's review the syntax of LW assembly instruction. Syntax of this assembly instruction is almost identical to LD assembly instruction because the first source register is S3 register, just like first line of instruction. And the offset is the same. Offset is 0x10. So we can copy this representation. Only difference between two assembly instruction is that as for second assembly instruction, the destination register is A6 register and the size of data that could be loaded will be 4 byte instead of 8 byte. So we can expect that after we run this assembly instruction, A6 register will be updated to hold this data because LW instruction support 4 byte loading operation. Now it's time to run this assembly instruction. So please pay attention to the value of A6 register because A6 register is destination register. So let me try it out. 1, 2, 3. Please take a look at this. A6 register is updated to have this value because LW instruction support 4-byte loading operation. Now that you understand the how LD assembly instruction and LW instruction works, later we will practice another debugging, so SD and SW assembly instruction later.